Ever wondered how to fit any nonlinear curve using MS Excel Solver? Curve fitting, in essence, is the process of constructing a curve that best fits a series of data points. It's a powerful tool used across a multitude of fields, from financial forecasting to scientific research. Now imagine having that tool right at your fingertips, integrated into a software you probably use every day, MS Excel. That's right, Mississippi Excel Solver is a potent tool that can assist you in fitting any nonlinear curve. With it, you can analyze and interpret complex data in a more visual and intuitive manner, enabling better decision-making. In this video, we are going to explore the ins and outs of curve fitting using MS Excel Solver. We'll guide you through the process step by step so you can start applying this skill in your own work or research. Stay tuned as we unravel the steps to fit any nonlinear curve using MS Excel Solver. Ready to dive into the fascinating world of curve fitting with MS Excel Solver? Our first order of business is to access the Solver tool. You'll find this gem under the Data tab in the Analysis group. If it's not there, don't fret. You'll need to add it from Excel Options under the File tab. Once you've selected add-ins, choose Solver add-in from the list and then click Go. Check the Solver add-in box and voila, it's added. Now let's talk data. You'll need to input your data points into two columns. Let's call them X and Y. For curve fitting, these could be anything. Maybe you're tracking the growth of a bacterial colony over time or the oscillations of a pendulum. Regardless, X typically represents your independent variable, and Y your dependent variable. Next, we're going to define our objective and constraints in the Solver Parameters dialog box. The objective cell should contain the formula you're trying to optimize. This could be the sum of the squares of the residuals, for instance. Set this to min, as we want to minimize the difference between our observed and predicted Y values. The changing variable cells are the parameters of your equation. Finally, define your constraints. These could be based on the nature of your data or the type of curve you're trying to fit. Once everything's set, it's time to let Solver do its magic. Click Solve. If all goes well, you'll be greeted with a Solver Results dialog box, indicating that a solution has been found. You'll see your optimized parameters, and your curve should now fit your data like a glove. But what if it doesn't? Well, you can fiddle with the Solver options, try a different solving method, or reevaluate your data and model. Remember, curve fitting is as much an art as it is a science. So, that's how you use MS Excel Solver to fit a nonlinear curve. It's pretty straightforward, isn't it? Let's take a moment to recap what we've learned. We started our journey with understanding the power of MS Excel Solver for curve fitting. We then delved into the step-by-step process of using it effectively. Firstly, we found out how to access the Solver tool under the Data tab in Excel. We then learned how to set up our data correctly in the spreadsheet, arranging our known and unknown values in a logical and easy-to-understand manner. Next, we discovered how to define our objective function and any constraints that needed to be considered. This was followed by the exciting part, running the solver and watching as Excel crunched the numbers to find the best fit for our data. Finally, we took a look at interpreting the results, making sense of the curves and understanding what they mean for our dataset. And there you have it, a quick and easy guide to fitting any nonlinear curve using MS Excel Solver. Until next time, keep exploring, keep learning. Now let's take the knowledge we've gained and apply it to a real-world example. We're going to look at fitting a nonlinear adsorption kinetic and isotherm model using MS Excel Solver. Adsorption kinetic and isotherm models are commonly used in chemical engineering and environmental science to describe how molecules distribute between the liquid and solid phases. Fitting these models can be quite challenging due to their nonlinear nature, but with the power of MS Excel Solver, we can simplify this process. Let's start by inputting our data points into MS Excel. Make sure to arrange them logically, as we learned earlier. You'll have your known values, which are the concentrations at different times, and your unknowns, which are the parameters of the model. Once your data is set up, we can move on to defining our objective function. Remember, this is the function that we want to minimize or maximize. In our case, we want to minimize the sum of the squared residuals between our experimental data and the model predictions. Next, we move on to the constraints. For our model, we might have non-negativity constraints, meaning all our parameters should be greater than or equal to 0. Now comes the exciting part, running the solver. Just as we did before, go to the Solver tool under the Data tab and input your objective function and constraints. Click Solve, and watch as Excel works its magic, finding the best fit parameters for our model. And there you have it. That's how you fit a nonlinear adsorption kinetic and isotherm model using MS Excel Solver. As with anything, practice makes perfect, so don't hesitate to try this out with different data sets. Stay curious, keep learning, and see you in the next video. Moving forward, we understand that things may not always go as smoothly as expected when using MS Excel Solver. Hence, in this segment we will address some common issues that you might encounter and provide solutions to troubleshoot them. Firstly, if you're getting an error message that says Solver could not find a feasible solution, it's likely that your constraints are too restrictive. In this case, you may need to adjust or remove some constraints to allow Solver more flexibility. Remember, don't remove all constraints at once, but rather try eliminating them one by one to see the impact on the solution. Secondly, if Solver is taking too long to find a solution, your model might be too complex. Try simplifying your model or using fewer variables if possible. Also, ensure that your initial guess values are as close as possible to the expected solution. This can significantly speed up the process. Lastly, if Solver is returning a solution that doesn't make sense, double-check your objective function and constraints. There might be a mistake in the way you've set them up. It's also a good practice to manually check the solution provided by Solver. This helps you understand the process better and catch any potential errors. Remember, troubleshooting is a part of the learning process. Don't be discouraged if you encounter issues. Stay patient, keep experimenting, and you'll get the hang of it. In the next segment, we'll move on to more advanced applications of MS Excel Solver. Stay tuned. Having covered the basics and troubleshooting methods, it's time to elaborate on how you can further your understanding of MS Excel Solver. For more examples of fitting nonlinear adsorption kinetic and isotherm models, be sure to visit AminulChem Innovation. It's a treasure trove of resources meticulously curated to help you master the art and science of MS Excel Solver. From detailed examples to in-depth tutorials, AminulChem Innovation provides valuable insights that can significantly enhance your learning curve. Not only that, but subscribing to the AminulChem Innovation channel also keeps you in the loop with new videos and tutorials, ensuring you're always up to date with the latest techniques and applications. As we wrap up this segment, we want to thank you for your time and attention. Remember, the path to mastery is through continuous learning and practice. So don't forget to subscribe to AminulChem Innovation for more insightful videos. Until next time, happy learning.